One of the methods that people often look towards to help them boost their soil life is compost tea. So in today's video, I'm going to show you how to build a particular type of compost tea brewer for less than the cost of your average weekly food shop. I've really enjoyed putting together this particular video because it's been really good fun getting hands-on, building stuff and playing around with compost and pumps and stuff like that. So I hope you guys like it. Now the cool thing about this particular design that I'm going to show you today is, although it's not completely original, there's some little quirks about it which are perhaps a little bit different to what others are showing you. And in fact, I'm going to show you one particular aspect that most other people that show how to make this type of brewer completely forget to tell you. And that's so important for actually making the thing work. The other thing which has been really cool about this is trying to do this on a budget and keep everything as cheap as possible. I've set a target of less than £40. I guess that's probably about $50. I think you could actually do it a lot cheaper. And in fact, originally I was kind of looking to do this for less than £20, sort of $25. If you've got certain material or equipment already, then I've no doubt that you could probably do this even cheaper than that. So as always, if you like this kind of stuff, please consider subscribing to the channel, give the video a like if you find it useful, and let's get straight into it. So just to be clear, I'm not going to talk about what compost tea is, does it work, doesn't it work. I'll leave that for another time. If you want to know more about what compost tea is, I'll put a link to another video I made in the description below. I'm going to line out all of the items that I've used for this in the description below and try and keep it as useful to you as possible. And let's get on with it. So the type of brewer that you've just seen working away is often referred to as a lifter, or sometimes called the compost lifter brewer. And that is because air is added at the bottom of the tank or vessel that you've got the brewer working in, and as it rises up this tube in the middle, it lifts water and compost material up the tube together, mixing it all with oxygen in the process before it's jettisoned out the top out of an outlet onto the surface of the water. This then sinks down again and the whole process begins over, and in this way you can get really nice currents circulating through your mixture throughout the brew whilst gently oxygenating in a manner kind of similar to a natural water course like a stream or brook. And this is what that kind of riser column or rig looks like. In reality, it's a pretty straightforward design. It's a tube, it has a couple of inlets on the bottom and an additional inlet where the oxygen is added in. The long tube extends up through the tank, through the water, and you have your outlet at the top. Now, depending on the dimensions that you choose to use, you can play around with the position of the inlets and outlets to suit the tank that you're using, and you'll want different lengths in order to achieve that. But once you've kind of set it up in the tank with clear water, you'll kind of see a little bit later in the video, in fact, you can see how you might want to kind of tweak those things. And that's the great thing about this system. It's all kind of plug and play, and you can tweak it in just the right way to minimize kind of dead spots in your tank with the currents that it creates. And so if you're utilizing more of your tank, especially if you're using a round tank, this can be a really effective way to get kind of mini currents that add to that brew cycle. Now, I said I would share a couple of things about why my tank or adaptation is slightly different to others that you might have seen. In most lifter brewer designs, the air is just added direct from a hose into the water. On mine, you can see here I've actually got an air stone that diffuses the oxygen into the water instead. So that means that you get finer bubbles kind of transitioning into the main tube before it mixes with the compost. You don't have to do this, but I like to know that I'm getting a higher volume of dissolved oxygen into the water with this particular brew system. So now we're going to look at the components I use. I have a pump. I've got 3 different types here. I suggest that you use, as a minimum, a 30 litre per minute pump as standard for kind of a brewer of upwards of 100 litres. You could go higher if you want, but I think that's a safe minimum to kind of overspec the amount of oxygen that you're getting in the water as the biological oxygen demand increases. Now I've got these all set up in my shed, which are super because one, I've got gravity on my side so I don't get any nasty kind of back runs down the line if there's ever a power failure, although I do recommend using a check valve perhaps in the Airline as well to stop that backflow. But then I can have the hoses running through the shed wall and straight out to the brewer tank itself. And that means that it ensures longevity of the pump and it reduces maintenance, which is great. Now I should also mention that I actually use a braided hose. You don't have to do this, but again, it just helps kind of durability and longevity of the materials that I'm using. So when it comes to the actual parts itself, well, this is the bulk of where it's at, and these are very cheap in fact. So it's a load of PVC piping. You can see the invoice for these items if you want to kind of freeze and have a look at that. So these are the components. We've got the long upright tube. That's the bit that it all kind of attaches to. I'll explain about that shorter length in a bit. Then we've got 4 elbow joints that are used kind of attached to the main central column in the rig. Shorter lengths that kind of give the character to the rig that we're using and help it fit the tank. Cable tie, I'll show you a little bit later. This is interesting. This is where the air goes in, and in fact it's the only component that I've glued. There's a fitting in here which I've used a PVC cement. You can see kind of the black from the residue of the glue, and that just means that it doesn't fly out when the water is flowing through. This is how it all fits together. It's actually super quick. I'll show you in a little bit of detail what I've done there with the air stone that I mentioned earlier, but as you can see, the cap kind of screws onto that, and you need a firm base for the air to go in, or else that will fly out. And it all just plugs together super easy. I think this is pretty self-explanatory, other than to say that I elected not to use glue for a very good reason. I could actually get a really tight fit on all of these components, and that just makes it easier to clean after each brew, which I'll explain a little bit later. The shorter lengths that I cut down, one thing I would say about kind of cutting the PVC tubing is do make sure you take time after you've cut them to clean up the burrs from the edges, or else they tend to deteriorate and end up in your compost tea solution over time. So a few minutes just to either file them away or sand them down is time well spent. And that is the rig assembled in approximately 1 minute. So super straightforward. Now I did say I'd explain a little bit more about attaching the air stone, and this is why you kind of need to glue that particular component together. There's a screw tap on top, and the Airline hose kind of goes through. I've put actually a sheath of hose pipe in that gap because it means that I can remove it pretty easy, and I get such a nice tight connection that I don't get any air escape as well. But you will want your Airline to kind of go through a nice airtight seal, and from that I then add the air stone. And you can see the cable ties that I mentioned earlier. They help hold the Airline in nice and close to the lifter rig, and that means that it all sits beautifully in the tank like this. You can then begin to fill your brewer, and this is the thing that no one actually tells you. When you're building and cutting the tubes, there's a really important consideration, and that's the amount of water, the volume that you're going to be brewing in. And that main lifting column needs to put the outlet above the water surface when the tank is filled. Now what I've done here is deliberately half filled the water level in the tank, so you can see what I mean. The water kind of just dribbles out. because the water level kind of equalizes in that tube and it sits very low down. Unless you've got a super aggressive pump, it's not going to put out enough water, enough oxygen for it to work effectively. So if we carry on filling the tank now, you will see that the pump kind of begins to work a lot more efficiently. And there it is, right near the top. You can go about 10 centimeters beneath the top of the outlet, but you can see straight away that the flow of water is much, much better. And this is also another really good reason for not gluing it together, because I can swap over to different lengths of tube for that central lifter column. Remember earlier I showed you that shorter column that I might use if I'm only brewing in half the tank. So it's a very flexible system, really kind of useful feature of it. Now here you can see how the system works with no compost in. You can kind of see that there's a nice current. We'll add some solution in so you can kind of see how it mixes around, which is super, super quick. If we look at the outlet here, you can see that kind of within seconds of adding it, it's already dropped to the bottom of the tank and circulating through the water. So a very efficient way. You get some lovely currents with this system. Now I mentioned that I don't glue my assembly together other than that one component, and one of the biggest benefits is for cleaning. The great thing about this whole system is it fits together so snugly with no pressure lost, but it comes apart beautifully too. That means you can literally break it down into all the components and either throw them into your sink like this, give them a good cleaning with a sponge, using some kind of antibacterial dish soap, or if you want, you could just chuck them in your dishwasher. I haven't tried it, but irrespective, I would definitely give them a rinse after they've been washed just to get rid of any residues. One thing I would say is the natural substances do congeal slightly around the fittings, so it's super, super important to clean it straight away after every brew. So just to finish off, here's a couple of shots of it running. There are lots of different brewer designs available. Everyone will tell you theirs are the best. I'm not saying this is the best, I'm just saying it's incredibly flexible. It does the job. I've checked it with my microscope to see how effective it is, and it does the job beautifully. It's incredibly versatile. You can make it very cheaply and kind of looks quite cool as well. If you think that it would be useful to look at some of my thoughts for upgrading this system, I've got some ideas about how I might improve it, then do let me know in the comments below. That does it for this video, guys. If you found it useful and enjoyed it, please do give it a like. That really does help. If you've got any comments, drop them in the comments section below. And if you want to see more videos that are trying to help you grow healthier, tastier food, then consider subscribing to the channel. Until the next video, I'll see you soon.